I was helping my daughter with her GCSE computer science revision earlier, and she had a question on merge sort, so I thought it would be a good opportunity to implement merge sort using C#. The idea behind merge sort is you're given initially an unsorted array, integers in this case, and it's a divide and conquer technique. So the idea is you divide the array in half, as close to the half as you can get, and then you merge sort the individual halves. And you keep doing that until you get down to lists of just containing one item. You then have to combine these lists back together again. So, and this is where we're doing our merge. So when you merge two lists back together, they end up sorted. And because the input of the merging is already sorted, we can then merge those two back together. And you keep doing that until we end up with our sorted list. So to do this, I'm going to create a new C# project, which is just going to be a console app in .NET Core. So just give it a couple of seconds to create the application. Okay, and we're going to start off by just creating an array containing some random values. So we have our unsorted array. And we'll start off with 16 values. Because we have a power of 2, we can nicely divide up the values into half each time. And we're going to populate these with random numbers in the random number source. And we'll just quickly loop through our array. And we'll give each element in the array a random number between 1 and 100. And then we need a way of displaying an array so we can check we've actually sorted it. So we'll create a helper method called display array, which just takes in our unsorted array. And we'll just write to the screen. And we'll just create a helper method which doesn't need to do anything fancy. We just want to do so we just want to display all the elements in the array separated by commas. So we can use string join for that. And we'll just make sure that's all working as we'd hope. Lost the window. Yeah, so this is our initial random data and it's unsorted, which is fine. So the next thing is we need to write our merge sort function. So we'll do this as a new function because it's something that we're going to need to call recursively because we want to keep sorting each half of the list. So the first time we call merge sort, we're going to pass in the entire list. Okay, so now what we need to do is split this list in half. So the first thing is we need to find where the middle of the list is. So our centre point is just going to be the length of the list, just the length of the list divided by 2. So then what we need to do is, once we've got the centre list divided by 2, we then need to sort the left hand half of the list and the right hand side of the list. So we're going to call merge sort again. So in C#, you've got something called a span, which you can create from the array, which is just sort of a view of that array in memory. So that view's got its start location and its length. So we can use that, and we create that using the slice method. So we're going to take a slice of our input array, and we're just going to take the first half. So it starts from 0, and we know its length is going to be centre. And the reason it's not compiling is because we've defined this to take in an integer at the moment, an integer array, and now we're using span, so we just need to change its signature slightly. And in this case, it's automatically converting our integer to a span, so that all works fine. So that's going to sort the left-hand side, and then we need to sort the right-hand side. So if we do the same thing again, is we just take a slice starting at that middle point and going all the way to the end. And once we've done that, once we sorted the two halves, we can then merge those two halves back together. So we're going to need another function called merge to stick those two back together. So we pass in our full array and also where the middle is, so we can work out which is the left and the right hand sides. And we're going to keep doing that until we end up with lists which have only got one item in. So we just need to check we haven't reached that stage as well. So all the time we've got more than one, we can keep splitting that list up and sorting the two halves. So the next thing is to write the actual merge function itself. So this center point is where, we're merging two lists together at this point. So like for example these two lists, but we're holding it in memory as a single. Put a pen to yours. So it's a single block of memory we're passing in, but we know the center point, which is where the second half of our list starts. So we can just rename that to be start of the right half. So the idea is we keep advancing along these. So we now have two lists in memory really. So we've got one which runs from 0 to just before start of right half, and we've got a second one that runs from there right the way to the end. And the idea is we have a pointer into these two lists and we compare each element in turn, and we then output the lower of the two elements. And we're going to put the output of the lower of the two elements back in our span, which means because we're going to be overwriting that data, first of all we need to take a copy of it. So we're going to call this, maybe we should call that results instead, and we can have a copy which is our input, or I'm not going to call it unsorted again. So because it's a span, it's got a to array method, makes it easy. So the basic idea is then we have a pointer to where we are on the left hand side, so let's call it left hand side, 0, and we have a pointer to where we are on the right hand side, so that's going to start up there. And then we can say if the element in the left hand side is less than or equal to the element in the right hand side, then we know that the left hand side comes first, so we can put that into our result. So we also need to know where we are in the result, so we have an offset. And then we can then move our left hand side on one position, and also we can move our offset on one position. So if the left hand side is not less than the right hand side, then it means that the right hand side must be greater, so we need to must be the smaller of the two, so we need to output that instead. And this time we'd move our right hand side pointer on, and again we'd move our offset on. So because we can do the offset in both halves of the loop, we can pull that out. Both conditions we can pull that out. And we keep doing that until we either run out of elements in the left side or we run out of elements in the right side. So we can have a while loop around this. So it's going to be a while the left hand side pointer is less than here, and the right hand side pointer is less than the length. We can keep going. And that's all going to work fine all the time. The left hand side is the same length as the right hand side. In fact, that's not even that case. We're always going to end up with some elements left over at the end. So when we get to the end, if we've exhausted all the elements on the left hand side, then we need to add all the remaining elements on the right hand side. And likewise, if we've exhausted all the elements on the right hand side, we need to add all the remaining elements from the left hand side. So it's not particularly easy to copy into the span, so I think we'll just do a loop. So we keep looping whilst we're still got some of the left hand side to go. And we just do that again and increase the offset again. And then we do the same thing with the right hand side. And then so that should have merged the two halves back together again. So if you think of it as being fed two lists in, and each list was already in the right order, and we've just merged those two into a single list of the right order. It's slightly more complicated because we're holding it in a single list in memory. So that does our merge sort, and then we can display the sorted data. And we can try this now. And fingers crossed. And that seems to have worked. So we'll just try it with a slightly bigger example. We'll try 32 numbers. That looks like it's worked as well. And because of the way we are splitting it, we can try it. We can also work some numbers which are powers of 2. So there's other ways of implementing merge sorts. This is quite a nice one because it uses recursion, but it's not necessarily the most efficient way of doing it. Thank you for watching.